Happy Friday, ladies and gentlemen. Mr. Eicher here for yet another video. Am I ever going to return? Well, it's questionable. So, today is Friday. You're learning about parabolas again. Basically, today's lesson is pretty much entirely a review of yesterday. Mr. Brack and I recognize that parabolas are tricky as your first type of conic section, so we scheduled 2 days to talk about parabolas. And if you're wondering about Chapter 7, well, we're right here with parabolas. You have a textbook assignment. Make sure you do your cumulative review on Schoology. There is no additional Monday assignment, X that. You'll notice I will not be around on Monday for learning labs, so you can stop by, but I won't be here. Teardrop. And then we'll come back on Tuesday. Well, you'll come back on Tuesday to do a practice quiz. You have a quiz on Wednesday. And then if all goes well, you'll be either very happy to see me on Thursday or very sad that I came back. We'll see on Thursday when I see you then. And then I will be back to review on this Thursday, and then you'll have your test on Chapter 7 the following day. So, we've been talking about these parabolas just to make sure that when I get back I have a review day with you before you do your test. So, you can enjoy these parabolas. We won't be tested on parabolas for another couple weeks. So do your best, but we will review parabolas a lot more after the Chapter 7 test on this day. Okay, so that's our schedule. Let's check out these review questions we got going on right here. These are your last pages of your notes. Again, the parabolas will not, N-O-T, not be on your quiz, and it won't be on your test. Just kind of shifted things around since I'm not around currently. So our first question we have is find the vertex, focus, and directrix of this parabola. So when you see a parabola like this, you're going to have to complete the square. You have to figure out, let's see, you have an x squared and an x. So we should probably collect the x's together and move the y to be all by itself on the other side to get it out of the way. So we have x squared minus 2x plus blank minus 15 equals, moving that 8y over so it's a positive 8y. And then plus blank. So to complete the square, remember we do the b over 2 and then square it. B over 2 squared. Our b is the 2 right here. So b over 2 squared would be a 1, so we're adding 1 to both sides. Then we factor this left side of the equation. We get an x minus 1 squared minus 15 equals 8y plus 1. We want the y to be all by itself so that we can put it into standard form. Standard form being y equals a x minus h squared plus k. If you can really read that, I'm not really sure, but okay, so we're going to subtract 1 from both sides. This negative 1 stays put. We have a negative 16 now, equals 8y. And then divide both sides by 8, so we get a 1/8 x minus 1 squared. And then the 8 divides with the 16, so we get a negative 2. So here's our equation. We're going to base everything off of that equation. We need to find the focus and the directrix of the parabola. And we have a little graph below to help us out. So let's scroll down there. So the vertex we have would be 1, negative 2. We can graph that. 1, negative 2 is down there. Let's see, we need the value. Does anyone know? Does anyone know the formula? Anyone know? Anyone? Anyone? Are you out there? No one's saying anything. 1 over 4a. That's really, really important formula. That is going to tell us how far away the focus and directrix are. So 1 over 4a. Our a value is this guy right here, 1/8. So we have 1 over 4 times an eighth. 1 over 4 times the eighth, that would be a half. So our a value is 2. So that tells us that the focus, it's opening up. The y, it's going to be opening up like this. So the focus is going to be on the inside, up 2 from that point, so go up 2. So it's right here is the focus. There's our vertex. And the directrix is down 2. So a couple dotted lines, that's our directrix. So the equation of the directrix would be 1, 2, 3, 4. So y equals -4. And the equation of the focus is 1, 0, or the coordinates of the focus, not the equation of the focus. I forget what else the question asked for, but we could do the LR. The LR is the LR length is the reciprocal of the a value. So the reciprocal of the a value would be 8. So we're going to go through the focus. We're going to go 4 to the right. We're going to go 4 to the left. I think I counted right. Yeah, close enough. And then our parabola is going to go through this LR, go through the vertex, and up through that other point. So the LR is this length right there. I might have asked for the axis of symmetry. The axis of symmetry goes through the focus and the vertex. So the AOS, axis of symmetry, cuts the parabola into two symmetrical parts. So that equation would be x equals +1. So we have the directrix, we have the axis of symmetry, we have the LR length, and we have the coordinates of the focus. I think that's all that we needed to solve for. Let's look at the next one. On this question, we're asked to find the equation of the parabola with a focus and a directrix. So it might be helpful to use this information, use this little graph here, focus and directrix. So the focus is at -1, 0, which is right there, -1, 0. And the directrix is at x equals 3. X equals 3 is right here. 3, 3, 3, 3. Okay. Now, the vertex is halfway between the focus, which is this one, and the directrix, which is this one. So halfway between those would be this point right here is the vertex. So the vertex has coordinates 1, 0. So that's a really good start on our general equation. Which direction is this parabola going to open? Remember, the parabola always catches. It's going after, it's trying to clasp the focus. So if that's the case, then the parabola is going to kind of look like this. And it's going to be pointing towards where the focus is. Because it's opening to the left, that tells us two very important things. Opens to the left tells us, numero uno, that our equation is x equals, not a y equals equation. Since it's opening in the x direction, it's a x equals equation. And that would be a y minus k squared plus h. The second thing that it tells us, since it's opening left, is that the a value is negative. If the a value is negative, you go that way. If the a value is positive, if the a value is bigger than that, then you open to the right. So we'll keep those two things in mind. We have our general equation y, there I go saying y. We have our general equation x equals a y minus k squared plus h. And we have our vertex coordinate, which is 1, 0. So we're going to put a 1 here. Well, let's see, 1 is h. 1 is h, 0 is k. So 1 here and a 0 here. All we need now is this a value. And I'd like you to pause the video and chat with your neighbor to see if you remember how to find that a value based on this given information in the graph. I hope you discussed that this distance from the focus to the vertex, this distance of 2, is equal to 1 over 4a equals 2. Solving for a, we would get 1 equals 8a, so a is 1/8. So we can write our equation as x equals 1/8 is a, y minus k, k is 0, squared, plus 1. To clean that up a bit, we would just say x equals 1/8 y squared plus 1. And that would be our equation of our parabola. That's 2 down, 4 to go. Let's check out number 3. All right, number 3, find the equation, the vertex, and the directrix of a parabola opening down, okay, opening down, looks like that, so the focus is down here, and the directrix is up here. It has a focus of 2, 3, and one end of the LR is at 4, 3. Boy, oh boy. Let's see. Let me maybe scroll down so I can use my grid a little bit. So it's opening down, the focus, okay, that might be enough. So we have the focus is at 2, 3, 2, 3 right here, focus. And the LR has a point at 4, 3. So this is end point of LR. Well, the LR is a segment that passes through the focus, and the focus is the midpoint of that segment. So like if this is the LR, the focus is right there, right in the middle, so these two are congruent sides. So that means the entire length of the LR would be this. Maybe I'll do it like a little blue. This is the LR. And that is a distance of 4 units. Remember a formula that we had with LR. LR is 1 over A. So if the LR is 4 units, 1 over A, then that tells us, multiply both sides by A, we get 4A equals 1. So A must be a 4th. That'll be helpful when we're finding the equation, so we use that A value. And remember, the A value actually, we were told the parabola opens down, so that means the A value is negative. So maybe I'll put a negative there. Okay, now what can we do now? I feel like I'm going to need some space up here, so let me maybe put this, this is the focus right here. So the focus is a certain number of units away from the vertex. We want this vertex right there, that point. How far away is the focus from the vertex? Well, it is 1 over 4A units away. 1 over 4A. And we just found A was this, so we have 1 over 4 times negative 1/4, which would be 1 over negative 1, which is negative 1. So it's 1 unit away, the vertex is 1 unit away from the focus. So the vertex is above the focus since it's opening down just by 1 unit. So we would have a parabola that looks like this, opening down, where the vertex is this point, which looks like 2, 4, 2, 4. And it looks like our directrix then would be 1 unit on the other side of the vertex, so this line, 1, 2, 3, 4, 5. So y equals 5 is the directrix. And, oh, we just need the equation now. So the equation would be, it's opening down. So since it's opening down, it's just a y equals. So y equals a x minus h squared plus k. We found right here the coordinates of the vertex, which is 2, 4. So y equals something, x minus 2 squared plus 4. And then the a value, oh yeah, the a value we have just way on the right side of the screen, right here. So the a value is negative 1/4. And that would be our equation. I think we found everything they wanted us to. Here's the equation. We have the coordinates of the vertex. We have the directrix. I think that was it. So definitely a lot of pieces, kind of a puzzle that you're trying to solve. Put the pieces together, see what kind of picture that you can develop, that you can observe in this characteristics of parabolas. All right, number 4, onward and upward. Number 4 says, find the equation of this parabola. You have the focus is at point A, and let's see, that's at 0, 2, it looks like. And the vertex is here, and those coordinates would be negative 1, 2. Negative 1, 2 is the vertex. All right, so maybe the first observation, notice that this is a parabola opening to the right. I'd like to see if you can write the general equation with the x's, the y's, the h's, and the k's that you would use, that the equation should look like this with numbers plugged in, but what should the general equation look like? Pause this video, see if you could write that. So the equation, x equals a times the quantity y minus k, make sure you have a k there and a minus, squared, plus h. So on the vertex, the x-coordinate is h and the y-coordinate is k. So we already have the h and the k. We're good to go there. We just need the a value. Remember, once again, I feel like this comes up a lot, this distance from the focus to the vertex, this distance is 1 unit, and that 1 unit is equal to 1 over 4a. Multiply both sides by 4a, we get 4a equals 1, so a is 1/4. It is opening to the right, so a is positive, and I think that's pretty good with that. Your equation would be x equals 1/4, y minus k, k is 2, plus h, which is negative 1. We should probably clean this plus and negative up, and we'll just put minus 1. Whew, there we go. 4 down. We have, I think, just 2 more. Is that right? Just 2 more? And then you can begin working on your homework. So let's get to it. Number 5, find the vertex, focus, and directrix, and graph the following parabola. Now, we've graphed parabolas like this before. There's a lot of approaches you could use. You could try to complete the square, which is what we're going to do. Put it in vertex form. You could use negative b over 2a. There's a lot of approaches, but since we want to find the vertex and focus, I'd like to put it in the standard form. So it's a y equals, so we're going to have y equals a x minus h squared plus k. That's the form we want it to be in. Currently it's not, so let's complete the square. We get y plus blank equals x squared minus 4x plus blank, and then minus 10. We'd like to figure out what number to add. Let me make this x a little better. We need to find what number to add to both sides so that this can be factored into a binomial squared. So it's going to be that negative 4 there, divide by 2 and squared. So that would be a 4 that we add to both sides. How about you pause this video, see if you can finish the equation, write the equation in the correct form that we have in blue there, and then see if you can identify the vertex, the focus, and directrix. And feel free to work with your neighbor and help each other out. Alright, so I get to this point. I have my general equation right here. And the vertex, hopefully, is pretty easy, right, to identify, 2, -14. And like we often do, we need this quantity, 1 over 4a. Well, in this one, our a is a value of 1, so it's just 1/4. So the focus is 1/4 higher than the vertex. So if the vertex is here at 2, -14, the focus is up by 1/4. So the coordinates of the focus would be 2, -14 plus 1/4. And the directrix would be the line down here. So you go down from the vertex, so horizontal line, so y equals -14 minus 1/4. So it looks like our focus, our coordinates for our focus, would be 2, -13 3/4 if I did my fractions right, and the directrix would be negative. Whoops. Tisk. The directrix would be y equals -14 1/4. But we're also asked to graph. So let's graph. We have the vertex, we have the focus over there. Let's find the length of the LR. The length of the LR is the reciprocal of A, so the length of the LR is just 1. This looks like it might be kind of a narrow-esque type of parabola. So let's see. How am I going to graph? Alright, so I'll do a little copy-paste job. Get rid of some of this stuff here. Guess I don't need that anymore. So we have 2, -14. 2, -14 is going to be way down here somewhere. And we're going to go up just a little bit. Up just a little bit. That's my focus. Okay, try again. 2, -14, we'll say that's here. The focus is right above it, like right here. The LR length is very short. It only goes about like that much. And then we have our parabola. Very, very narrow looking parabola. My apologies that the graph didn't work. We could have made it work. We could count by 2s, I guess. Well, maybe not 2s. We could count by something different, but you get the idea. You just graph the parabola. You use the LR, the focus. The LR goes through the focus, and you can use the vertex right there. All right, on to number 6. Number 6 is another example where you have to complete the square. So I'd like to give you a little bit of time, see if you can complete the square correctly on number 6. Pause this video, see if you can do that. Alright, so to complete the square, I added 9 to both sides and solve for x. Notice that this is x equals parabola, so it's going to open to the right or to the left, and since the a value is positive, it's going to open to the right. The focus will be on the inside. Excuse me. From the general formula, this is k and this is h. So our vertex would be -24, +3. And the grid is definitely not going to be big enough. The focus is to the right, so this distance is 1 over 4a, which again equals 1. So we have 1 equals 4a, a is 1/4. Excuse me. Let me say that again. So our a is 1. This distance is 1 over 4a. And a is 1. So that distance is 1/4. That is the distance from the vertex to the focus. So we need to take these coordinates of the vertex. We need to shift it to the right 1/4. If you're shifting to the right 1/4, that's going to change the x-coordinate, not the y-coordinate of the vertex. So the focus is going to shift to the right 1/4. So right, the vertex is here, the focus is right there. So you'd have negative 24 plus 1/4, comma 3. That would be negative 22 3/4, comma 3. Would be the coordinates of our focus, and there's our vertex. And then lastly, the directrix is a vertical line which is 1/4 away from the vertex. So if you need to go to the left from the vertex, that would be the directrix is a vertical line, x equals, and it would be negative 24 minus 1/4. So our directrix equation would be negative 24 1/4. That was number 6. So we've had 6 practice problems. I hope you're feeling a little more comfortable with this topic. You have some more practice in the textbook tonight. The last thing I wanted to note was at the bottom of the page. Some students find this summary helpful. So let's complete this. See if I can get this on. There we go. So for this summary, I believe this is in your textbook in Chapter 8, Section 2. So if you missed something, you could check there. You have 4 types of parabolas. You have A is greater than 0 parabola. That would be opening up. Oh, I guess I draw it here, opening up. And you have A is less than 0. When A is negative, you open down with the parabola. The vertex is this point, or this point. The axis of symmetry is a dashed line that cuts it in half. It goes through the h, so the axis of symmetry would be x equals h for both. The focus is 1 over 4a higher than the vertex. So we would have coordinates, or a general formula would be h, k plus 1 over 4a. Or if it's upside down, it would be h, k minus 1 over 4a. The directrix is that vertical line across like that, or this vertical line. So sorry, I said vertical, horizontal line. Y equals, you take the k coordinate and do minus 1 over 4a. Or if it's on the other side, you do y equals k plus 1 over 4a. And then we have the orientation, so it opens up. This one opens down. And the length of the LR, using the form that I like to use, would be the reciprocal of a, which is 1 over 4a. If you use the approach that Mr. Brack likes, then you would use the 4p as the length of the LR. So it's really important to note, or helpful to note, that when you're talking about the directrix and the focus, there are very similar ways that you calculate those. Notice right here this k, and then one's plus and one's minus, depending if it's opening up or down. But it's that same quantity, 1 over 4a. All right, and then finally let's look at horizontal horizontal parabolas. Right over here. So a horizontal parabola, meaning opening left or right, we would have horizontal opening to the right would be like this, opening to the right when it's positive, and when A is negative it opens to the left like that. The focus is in here. The focus is right there. The directrix would be this dotted line, or this dotted line. The axis of symmetry goes through the y coordinate, so the axis of symmetry would be y equals k for both. That would be this line. It's the AOS. The focus is 1 over 4a to the right of the vertex. So if you have h plus 1 over 4a, comma k, would be the coordinates of the focus, or if it's to the left, like in this one, this distance is going the other direction, that would be h minus 1 over 4a to the k. The directrix is that dotted line, so that would be a x equals the h minus 1 over 4a. And if it's on the other side, it would be x equals h plus 1 over 4a. And then lastly, the orientation. This one's opening to the right. This one's opening to the left, since a is less than 0 or a is greater than 0. And then the LR is the same formula. It's the reciprocal of 1 over a. And it's a distance, so it's the absolute value of that. All right, that ends the second day of parabola practice. I hope that you're helping each other, asking questions, trying to figure this stuff out for yourself, and make sure that you're keeping up with the homework assignments, and I will see you next week.